Welcome to Renaissance Charge Videos. I'm Rick Friedrich, and today we're going to look at the EMP generator, I guess. I haven't really named it yet. So this is also a dual pole double stack motor, just as this one. You will notice the difference that there's more coils. There's actually 24 more coils. They're all the same. There's 3 different types of coils. The rotors are exactly the same. The coils are exactly the same as this regular. And the frame, though, is, you can see, 7 inches rather than 6 inches. And also the support rod's frame is 1/4 inch now. Now normally we're making those double stacks slightly bigger than the single stack, which has got very thin support. So we beefed this up. It's 25 pounds. So there are 3 different types of coils, even though they're all the same, different functions. The 4 corners are the motor coils on both the top and the bottom, and these 4 coils here are the generator coils, and those outputs are right here. Now we've got 12 more coils, 8 on the outside and 4 on the inside, so that we have 12 on the top, 12 extra on the bottom. These we call EMP coils. Now I showed a video some years ago of this prototype example, and this was only 1 stack, where we have some generator coils, or generators, 3-phase on the top and the bottom. I've showed this many times at my meetings. We have the latching relay that rotates the batteries. We usually ran that at 24 volts. So here we have it the same as double stack, and we've improved upon what I wanted to do was space out these EMP coils, is what I'm calling them, a little bit farther away so they're not touching. Now the ones on the inside are touching, and I couldn't do anything about that without changing the whole setup with different rotors and so forth, and I didn't want to do that. So why do I call them EMP coils? Only this row of coils here is where the magnets are passing the cores of these coils. These ones are not influenced by the magnet, only indirectly through the motor coils pulsing. And as you will see, maybe, the generator coils, when I pulse them in a little bit. So what I found was, when I used to have, when we start this up, you'll hear a little pulse. Tick. It's really not noticeable because we've turned down that to a very faint level. Now we used to make this self-start with that pulse, but it's a little bit, can get a little bit too powerful, and at the higher voltages it may even blow out the MOSFETs, even with the charging battery hooked up. So we discontinued that and turned it down. But I was showing in a previous video a long time ago where I had a magnet way over here, and when we turned it on, that pulse would actually spin the magnet. So it made me think, well, I could probably collect some of the energy from the impulsing, the EMP, every time you turn that motor coil on suddenly like we were doing, and discharge and turn it off suddenly, we have this EMP effect. Now it's just a minor one. This is not something that's going to really, I mean, it can disturb your electronics within a close range here. I've had computers go funny on me right from the beginning of me doing this technology, these experiments, but those were only very close by. So what we decided to do was just try this out, and of course I did it right here, and that was a success. It's a curiosity, and like I've said in the previous video today, when we think about trying to do a free energy device, we have to decide, is it worth it? Is it, or if we add a new feature, is it worth it? Is it worth the material cost or the hassle to assemble it? This was quite an ordeal to put these together. Initially, this is 25 pounds, and now a customer wanted it, so we made a bunch of them, and we have 3 extra right now that we can sell. Otherwise, we will not continue selling it. If there's an interest, we will continue to make another run of these, which will take about a month and a week before we could get the materials in. So if you want to order these, there'll be 3 available, and after that, if you order, you'll have to wait about a month. But anyway, we had to decide, is it worth it? And I think it is. For the extra cost in coils, it's definitely interesting. Now some of you might want to try and do something like this, where you add some more coils externally. What we did here is we made a little bit more of a space than we had here. These were right up against the motor coils, and these ones we've added a little bit of gap, except the inner one doesn't have the gap. So what we also show here, which we haven't shown before, really is the 2 separate boards. We made the power board separate from the Arduino driver board, and that makes it more convenient to place, especially when you have a double stack. So we will be upgrading these boards more and more. So what we found is, so what we have here on the front is 4 outputs. So we have the external 8 coils here going to one bulb, and the bottom one's going to another bulb. And then the internal 4 are also going, and of course they are half the voltage than the other ones. And I think they're a little bit less than that, the inner ones, because they're touching a little bit close, a little bit less than the outside. So what else should we say here? Let's get it started. Make sure these don't time out on us. So what I'll do is show, probably won't be able to hear me much because my external microphone's not working. I actually videoed this, did the video, and found out the noise was not very good, or the sound wasn't very good, so I had to do it over again. So let's look at this. You can see the amp draw once we get started. Hold on a second. So you can see it starts off at a higher amperage and it comes down. The movement of the Hall will definitely affect the RPM and the power level. Same with this potentiometer. So we made this to run at 48 volts. Now right now it's just 12 volts. 12 volts input, 12 volts charging, and this is just an isolated battery. It's got this common ground with the input, but we want to isolate that so that the spike does not come into the Arduino code or processor, as well as the gate driver chip or the gates of the MOSFETs. You could put an isolation transformer, but you still have to put a good filter on that, and we may offer that in the future. The problem with that is you'd have to have various models for various voltages. So this is a convenient way to isolate that. Now, if we're going to run this at 48 volts, we're going to have to move this Hall a little bit backwards. So you notice those lights coming on when I actually go like this and draw less amperage. You can see it's charging the battery. Now this is under charge, so it's higher. This is under load, so it's lower. When we turn it off, it will balance out. So if we're running it at 48 volts, the timing will have to be turned down by this pot. So the on time will have to be turned to the left. And if we are actually loading this down physically, then we also will move the timing of the Hall. In this case, my left. This way. So now, when we short out the generator coils, the motor speeds up. And it does affect those EMP coils because the motor coils are affected. So now I'm shorting it out, it's going faster, drawing less energy. The charging rate's affected by the motor coils all the time. So when we go and spark this, you can see. So let's turn it off. So you notice they're still lit up. The motor is totally cut off. Now I will disconnect the input. Well, we can disconnect the output too. And even with it connected, there's no activity affecting, there's no magnetic, the magnetic field is not affecting the outer coils and the inner coils, as you can see. However, when this thing was winding down, you still have a generator action here, which was in the form of an impulse, and they were still affecting those bulbs. And you can see it actually got brighter. So anyway, it's a curiosity. We made this. It's not the greatest thing in the world, but it's very interesting. So we have these available. They're 25 pounds heavy, and we'll have them on the website by the time this video is uploaded. So I think that's it. Thanks for watching. We'll see you soon.